Hi everyone, this is Mrs. Treese here with the last video in our stoichiometry unit over percent yield. Okay, so we're going to go ahead and jump on in. You're definitely going to want a calculator to solve these problems and also a periodic table. Okay, so we're going to start by doing a real world kind of example of where you have used percent yield before. All right. So it says your chemistry tests have 25 questions on them. If you get 18 out of 25 questions correct, what percentage of the test were you correct on? Okay, so how would I solve this? All right, I'm looking for what percentage right, my percentage right or my percentage correct. So I got 18. There were 25 possible questions. So I got 18 out of the 25. So 18 over 25, it's a percentage. So because it's a percentage, we're going to multiply times 100 and then solve. So 18 divided by 25 times 100 means that I would get a 72%. You guys probably have recognized this because this is probably how you solve for most of your grades if, you're just given like 14 out of 20 right or whatever. Okay, so this probably is kind of familiar, but this is essentially percent yield. All right, so our equation for percent yield, I'm going to come write it and then I'll define the terms, is that our percent yield is equal to our actual yield divided by our theoretical yield times 100. And that would be our percent yield. So actual yield divided by theoretical yield times 100. All right, so let's define those terms. So our actual yield is I always call this one our real world. This is our real world here. Okay, so our actual yield is how much was actually produced. This is typically going to be a lab value, how much you actually made in lab. So we don't always make as much as we could in lab because we make mistakes. We're not perfect. So we don't always make the amount that our experiment says we should. Okay, so this would be how much we actually made. Then our theoretical value is I always call it our perfect world value. So if we did everything perfectly and made no mistakes, this is how much we should have been able to produce. And while the actual typically comes from lab, our theoretical comes from calculations. We have to solve for our theoretical. It comes from our calculations. Now, occasionally your actual and theoretical will be given to you, but most of the time we're going to have to solve for our theoretical yield through our bestest buddy, stoichiometry. Yay. Okay, so we're going to start with a really simple one where we don't have to do any stoichiometry. Then I'm going to do one with stoichiometry with you, and then have you guys do one with stoichiometry on your own. All right, so let's start with this first one. So this first one says a chemist produced only 6.58 grams of a compound, although her calculations indicated she should have produced 9 grams. What is her percent yield? Okay, so first thing we need to do is identify our actual and our theoretical. So it says she only produced this. All right, so that's going to be our actual, kind of concluding that she only produced it. And then the other one, 9 grams, is going to be our theoretical. I'm just going to write Theo there. It says calculations that she should have made this much. That kind of clues us in, should have made or should have produced. That would be our theoretical. All right, so then since we have our actual and our theoretical, we're now able to plug it into our equation and solve for our percent yield. So percent yield is equal to our actual, which would be 6.58 grams, over our theoretical, which is 9.0 grams, times 100. So 6.58 divided by 9.00 times 100. Plug it on into your calculator. Both of our numbers have 3 sig figs, so our answer should have 3 sig figs, and we get 73.1%. Now, since this is a percentage, really we don't bother with sig figs very much, so just make sure you always round to 1 decimal place. Okay, so that one is nice and straightforward. Gave us the actual, gave us the theoretical. So now let's look at our next one. So our next one says water was decomposed by the following reactions. Calculate the percent yield of oxygen produced if 36.1 grams of water react and 27.3 grams of oxygen are actually produced. Okay, so right here we have 27.3 grams of oxygen actually produced. So that does give us our actual. Now, we don't actually have our theoretical here because look, we are looking for our percent yield of oxygen, but we're given grams of water. So that is not our theoretical. That's how many grams of water reacted. So what we'll have to do is we'll have to take that and convert it to grams of oxygen. And that will give us our theoretical, because if I have 36.1 grams of water reacting, it should, if we do a stoichiometry problem, it should tell us how much we should have made based on starting with that 36.1 grams. So make sure you pay attention, kind of ways that it clued me in that it wasn't my actual theoretical yield. So I'm looking for the percent yield of oxygen. That's water, so those don't match. And then also water is a reactant. So that's going to be something we start with, not something we produce. So it has to be one of the products as well in order to be a percent yield. So we're going to start by converting that 36.1 grams of water into grams of oxygen. Okay, so step 1, take what's given. So 36.1 grams of H2O. Is grams of H2O what we want? No, it's not. So we're going to drop it low. And kind of where we're at, we did have a balanced equation already, but where we're at in this problem now is get to moles. So we have grams, we're in grams, we need to get to moles, so we're going to use our molar mass. So you would calculate that by adding up all the masses on the periodic table. The molar mass of water is 18.02 grams. All right, and your molar mass is always equal to 1 mole. So equal to 1 mole of H2O. All right, now is moles of water what we want? Nope, we want to get to oxygen. So now we are, since we're in moles, we're going to do our mole to mole ratio. So here, for every 2 moles of water, it produces 1 mole of oxygen. Again, so that comes from our balanced chemical equation. So 2 waters to 1 oxygen. Then is moles of oxygen what we want? No. So if no, drop it low. We want to get to grams of oxygen. So again, we're going to use our molar mass. 1 mole of oxygen is equal to the molar mass. This is O2, so we do need to multiply the molar mass of oxygen from the periodic table by 2, which would give us 32 grams of oxygen. Then we would multiply across the top and divide by the bottom. So I'd have 36.1 times 1 times 1 times 32.0, and then divide by that by the product of the bottom there. So go ahead and plug that into your calculator. And when you do, you should get 32.1 grams of oxygen. And so this is our theoretical yield. We had to solve for it because we didn't start with that. It gave us grams of water. So this is our theoretical yield. All right. So now we can take our actual and our theoretical and plug it into our equation. So our percent yield is equal to our actual yield, which is 27.3 grams, over our theoretical, which is going to be 32.1 grams, times 100, and plug it on in to your calculator. And when I plugged it in, I got 85.0%. All right, so that's that one. So we're going to do one more. I'm going to have you guys do it. I will give you a little hint before I send you off on your own to do it. This one does involve stoichiometry, and I just want to give you a little reminder here that methane is one of our organic compounds, and methane is CH4. I'm just going to go ahead and help you guys at least get the reaction started. It's in a combustion reaction, so it reacts with oxygen. Anytime we have combustion, our products are always CO2 and H2O. So hopefully giving you the reaction just gets you in the right direction on this problem if that's something you struggle with. But I want you guys to go ahead and attempt to solve this one for me. All right, so pause the video, try to solve this problem. When you're done, restart the video and we'll go over it. Okay guys, let's go over it. So first thing is we are starting with 32 grams of methane in a combustion reaction, and we produced actually 30 grams of water. So this is our actual, didn't give us our theoretical, but we can solve it by converting that 32 grams of methane into grams of water. So first thing I did, wrote and balanced my chemical equation. Coefficients are 1, 2, 1, 2. And then after that, I converted from grams of methane into grams of water. So 32 grams of methane, used my molar mass, then my moles-to-mole ratio, and then finally my molar mass of water, multiply across the top, divide by the bottom, and that gives me that I should have, in theory, made 72 grams of water. So percent yield is our actual of 30 divided by our theoretical of 72 times 100, which gives us a percent yield of 41.7%. Okay, guys, hopefully this was helpful. I will post a practice worksheet for you guys over this just to make sure that you have got it and that you're good to go. All right, thanks, guys. Bye.